Welcome everyone, a very warm welcome to today's expert webinar on Azure Databricks. I am Ankita from SpringPeople. We are India's largest enterprise training provider. I will be a moderator for today's session. We are thrilled to have you with us for this exciting session. Today we are going to explore how you can make Azure Databricks. But before we get started, let me introduce you to our esteemed speaker, Mr. Rammohan. Mr. Rammohan is an accomplished SQL Server DBA with over 2 decades of hands-on experience in database and administration, design, and optimization across multiple environments. He is proficient in managing SQL Server versions from 2000 to 2017 and excels in database migrations, upgrades, and troubleshooting performance issues. With a rich 16-year background in training, he has delivered over 700 batches at top institutes like MindQ and Visual Path and has conducted corporate training sessions for industry giants like Capgemini, Genpact, and ICICI Bank. Ram holds multiple certifications, including Microsoft Certified SQL Server Technology Specialist and IT Performance Tuning and Disaster Recovery Solutions. His contributions to SQL Server forums and mentoring efforts demonstrate his commitment to knowledge sharing and professional development. Join us for an insightful webinar on Introduction to Databricks, working with commute in Azure Databricks, mounting storage, and writing transformations using pyspark. Now, participants, if you have any questions, please do share them in the chat box. They will be answered at the end of the session. Without further ado, let's start today's session. Over to you, Ram.
Thanks, Ankita. Hi, good evening, everyone. So let's get started. So today I am going to cover about the Azure Databricks, which is an latest and advanced technology, and which is one of a leading skill in the market for implementing the transformations and the ETL mechanism using the Azure Cloud Services. So I just want to start with the basics. This is how we can navigate to our session. I want to explain you what is the concept of an ETL, how we are implementing an ETL. Previously, it was there from the past 2 decades, and we understand what is the need to drive for a latest technology like Azure Data Engineering and the tools of Azure Data Engineering like Azure Data Factory, Azure Databricks, what makes us to search for a new tool. And then we will start discussing about the latest mechanism of using Spark, the architecture of a Spark, and then about the Databricks. And then I will show you how to implement a Databricks for working with different sets of an transformation. So let me start with the first concepts, that is an ETL. As you all know, ETL stands for the extract, transform, and load, right? So we are receiving the data from the varieties of sources. Traditionally, whenever we are using this on-premises, we used to store the data in different varieties of sources. In varieties of sources, like every source of an information, like I'm working in an organization. For example, that organization is going to store the information related to sales, okay, related to in marketing, related to some products, related to vendors. They are going to maintain their own information. Like some people, they will maintain the infrastructure using SQL Server and store the data inside it. Some people will use other RDBMS. Some people will use SAP ERP system. Some people will use CSV files or an Excel files to store the data. So my data was widespread in different sources. So in order to, like, the companies came up with a process. Instead of performing an analytic on each and every individual sources, we can call it as data silos. It is becoming a challenge or a problem. Like it is ending up creating a lot of duplicate values, lot of redundant values, some stale data. Rather than that, why can't we implement one single data warehouse where we can store all the data as one single central repository and all the teams can able to fetch the data from that central repository. Along with that, we will be able to apply a lot of PI, like we can able to convert the data into the form of a report, dashboard, So the business can implement the data-driven decision making using the enterprise data warehouse. So keeping that in mind, we are implementing this process called an ETL to extract the data from varieties of sources like the SQL Server or the Oracle or the CSV files where the data was stored. And we are transforming the data into one single format where the business actually wants to see the data. And finally load the data into the destinations. So this is the concept of an ETL. And there are many tools that we have been using from such a long amount of a time to implement this ETL. Like we have a tools called SSIS, Informatica, and Data Stage. Lot of tools are there in the market from over 20 years. But with the implementation of the big data engineering, we are running into some challenges that we are not able to cope up with the load that was being generating with the implementation of the big data. Like the data volume has been drastically increased. Previously, we are working with several MBs of a data or several GBs of a data. Currently, we are able to work. Currently, the data was heavily grown up to several petabytes and an exabytes of a data. And even the variety of a data is also drastically changed. So previously, we are just working with some kind of a tables or any RDBMS sources, or mostly we will be working with the files called some Excel or a CSV files. But coming to the current situation, we are going to work with a different platforms. Like we are going to work with the data that was stored in the disk storage, the data that was stored in the cloud-based applications, the data that was coming in the form of NoSQL applications, data coming in the form of streaming audio video content, logs, and many more things. Okay, IoT devices and many more things. So since the volume and variety of the data has been drastically changed, the existing tools like Informatica, SSIS, they fail to deliver the same ETL mechanism. Whatever they are using, they start seeing the failure mechanism. They are not able to cope up with the current volume. They are not able to process the variety of a data, and even the velocity has been increased. Like previously, we used to process the data once in a day or once in every 6 hours, uh, and currently we are going to work with the data that sometimes it may be every 1 hour we need to refresh the data, or sometimes on a ad hoc basis. My customer is saying that I want to see the data every 5 minutes. I want to see the live data. So in order to process these business requirements, the existing systems are failed to deliver. So which needs a drive to come up with the latest technologies. Moreover that, all these existing platforms, we are running on the virtual machines, which is a traditional hardware. So at some point of a time, suppose the load has been increased, the data volume has been increased. So I have to scale up my existing storage devices, or I have to scale up my compute engines with the number of CPUs, amount of memory up to some extent. But whenever we are reaching that limit, we may be further increasing the amount of resources, making the system to be so powerful and able to cope up with the workload. But by increasing the number of resources, by scaling up the current system, we will be reaching at a point, at some time, we will be in a situation that we cannot able to go beyond a particular hardware configuration. We are blocked there. So this infrastructure scalability issues, the maximum storage is already reached. The maximum compute is already reached. I'm in a situation that I'm not able to scale up more. So I have to reduce my workloads and evolving business needs. Many companies nowadays, they are calling that, hey, I am going to business. I want the business report to be published with the complete data analytics, data insights, and data has become the fuel for every organization nowadays here. Even if you are going for a free tools like the Swiggy or whatever the services that you are using, they are going to send you an insight of a data where you can able to identify, hey, in the last 1 year, these are the orders that I have made. Okay, and that data is so informative, you can drill down to a particular point, identifies how many times you ordered from the same restaurant, how many times you ordered the favorite dish. Okay, what is your favorite dish? Okay, so you can able to get the complete insight of the information by going through the data analytics. That much level the data is being used nowadays here. So every business, they want to view the complete 360 degrees of a data. So in order to implement that, the existing tools cannot deliver this. So we are actually looking for an advanced technology which can help us to implement the big data, handles the variety of a data, handles the huge volume of a data along with the velocity of a data. Okay, so there comes the main difference here. So we are going to learn today about the advanced tool which can help us to process huge volume of a data, the variety of a data, and the velocity of a data by using the traditional processing. If you are performing the operations, okay, that runs more than around, for example, 12 to 15 hours, I will be able to complete the same process within 1 hour using the Azure Databricks. So what is exactly making the difference? The main concept here is we are using a latest computing mechanism that has revolutionized the entire data processing and the compute technologies, that is the Apache Spark mechanism. So instead of using a traditional virtual machine for processing the loads, I will be using a latest mechanism called Apache Spark systems, Apache Spark cluster. So what is this concept of Apache Spark is? It is extremely fast, super powerful analytic engine to use or to implement large scale data processing. So it handles both your structured data, which is stored in the form of tables and RDBMS, and as well as it will also work with your unstructured data, which is going to store in the form of the files, CSV, JSON, Parquet, all the files. It is going to process the data in memory. So most of the time, what happens is all the data will be stored in the form of a disk. Okay, the main contention will be observed at the disk. So reading the data from the disk, writing the data into the disk, that is the one which is actually causing an contention. So in order to minimize the contention, the Spark uses in-memory data processing. So we can able to process all the data in memory. So reading and writing from the disk is much slower whenever you are performing an operation, the reading and writing from the memory. So we are using this in memory to enhance the performance of your workloads. And it will run 100 times faster than even your Hadoop. Okay. And it is using an horizontal scaling mechanism. The concept of horizontal scaling is previously whatever we discussed is a vertical scaling option. Means I have only one server. I'm running a server with around 4 CPUs, 8 GB of RAM. If that is not sufficient, I will increase the resources to some more extent. If that is not sufficient, I'm going to increase the resources to some more extent. I'm going to increase it furthermore if you are running short of resources. So at some point of a time, you will be reaching to a place where you are not able to further increase the number of resources here. We are blocked. Okay. And in Spark, we are using an advanced mechanism called horizontal scaling. So what is the concept of horizontal scaling is? For example, if you consider a lab, a computer lab, which you are which you have seen in the offices or your educational institutions, we have 30 plus systems, right? If I am going to combine the power of all these 30 plus systems, 30 plus computers, okay, into one, so it is going to give us more powerful compute option for me. Even suppose if we are running short of these 30 computers, I need more and more resources. I have to process several terabytes of a data. I already peak. I don't have a sufficient resources to process the data. So in that case, what I'm going to do is I'm going to add another 30 more instances to it. Another 30 more instances. These are the cheap computers, basic computers that we are using. And there is no limit for us to increase the number of systems which can be helpful for a processing here. So that way, we don't have any limit to the number of systems that can be added as a part of computing. So we can increase up to several hundreds and thousands of servers into one single compute, and we will be able to perform the operations using that compute. So it is following the highly scalable architectures where it allows you to run the process on hundreds of machines. And one more advantage of using this Spark is it supports the parallel processing. It supports the distributed processing. Okay. Say for example, so in case if we have 30 systems, I want to process the data of 1 terabyte. It is going to distribute the data across different partitions, and it will run all the process. Each partition will be taken care by one CPU. So I can able to run the process in parallelism, which can help us to enhance the performance of our process. So that's another advantage we have with the Spark. So, and one more advantage of a Spark is it is going to support a variety of use cases here. Maybe I want to use a Spark to implement the batch processing, like periodically. Every 1 hour I used to receive the data from a customer. I need to process the data, transform the data, and then load the data to your destination. Again, after 1 hour, I used to get a new data, okay, new set of a data. So as soon as I receive the data, I will process the data and load the data into the destination. That we can call it as an batch processing. And sometimes we are going to receive the data in the form of a stream, so continuous. Okay, so previously we are going to get the data in the form of interval, like every 1 hour, every 30 minutes, every 5 minutes. So you can schedule some kind of an interval. Based on the interval, you are going to get the data in the form of small chunks, but in the form of a streaming ingestion. Okay, say whenever you have performed an operation on the source, immediately the data will be flowed to your application here. Say you are using a scanning application like a door entry scanning. So it checks your iris, it checks your credentials using your iris. If you are valid user, it will allow in. So I created a pipeline. Each and every user, as soon as he logged in, I need to collect the information of a user here. So I'm not waiting for next 1 hour or 30 minutes. Whenever the user enters the organization, I need to know the complete details of a user and at what time he entered. So I am getting a live information here. Any information that was omitted in the source, I need the information. We are going to get the information immediately. That is called the streaming ingestion. And then we will be implementing the machine learning algorithms using, we can create several models, and we are going to implement some kind of a projection of a data using your existing data sets. That we can call it with an MSN machine learning. And we are going to use the same Spark engine for implementing the advanced analytics as well. So one single tool, but it is able to capable of delivering different operations. So that's the power of a Spark. Okay, so you can think about like what is Spark and what is Databricks. Databricks internally uses the Spark mechanism. Actually, the Spark is an open source that was built by this organization called the Databricks only. Okay, so they are released initially as a free tool, open source, and then later they customize it and created a proprietary product called Databricks. So the main revolution is using the Spark cluster technology rather than using your traditional virtual machines. Okay, so these are the challenges with the Spark that we are facing. Being an open source product, infrastructure management is a problem. Say today I took one cluster, I used the cluster, and tomorrow there is no guarantee that cluster is still available. And if I need some more clusters or some more servers to be added to the cluster, sometimes we may not be able to getting those clusters as well. So these are the kind of challenges I used to face whenever I'm going to work with the Spark engine. Upgrade challenges. Again, it's a free source. So the rolling updates to keep the tools and the software up to date are missing while using the Spark. And it does not have a lack of user interface. So handling the Spark, performing an operations with the Spark is sometimes difficult. We need to run a lot of code to start the Spark working, and we need to perform an operations using that Spark. Everything is a manual configuration, and we don't have a tooling and an integration complexity. Suppose I want to use this Spark to integrate with different other technologies, like the storage, where the data is available in Azure Data Lake storage, or some other services like Data Factory, where the actual data ingestion happens, or any kind of an ETL pipeline. Or if I want to further implement some kind of automation, so monitoring, I cannot able to implement these things because it does not have much of an integration complexity. And it is very difficult to work with a collaboration. Like, say, we are all the people working in the same project. I have completed some kind of an analysis, and I want to share your analysis with you. So this is another way. We don't have this kind of a collaboration that is available in the Spark engine. So these are all the things. Okay. So these are all the things that is making the Spark difficult for end usage. So then Databricks come into play. Okay. So underlying the Databricks, they are mainly using the Spark clusters only, but it is a fully managed and optimized platform for running the Apache Spark. For the users, they are creating a simple interface. They are creating a UI to set up the Databricks environment, and you can able to easily work with the Databricks environment and to perform an operations using the Databricks environment. And it has a lot of tools that are supported inside the Databricks environment, like DBFS, which acts as a Databricks file system. And there are a lot of tools like Databricks IO and Databricks clusters. So using the tools, you will be able to perform a variety of operations inside it. It is providing an integrated workspace where you can able to write the code and share the code between all your team members who are working on the same project. I can say I have developed some code and I can easily share the code with you by providing you an access to that workspace. And I can able to control the access if I want to grant you the read permissions, or if I want to grant you with the write permission, I will be able to grant an access on it easily here. So that is another advantage using this Databricks. And it is allowing you to scale up, scale down your infrastructure by using the clusters. And Databricks is going to provide you the backend hardware resources, how much compute you want to use for your clusters. You want to increase whenever there is a peak load on the server, or you want to reduce the amount of configuration that is easily configurable using the Databricks clusters here. So we can implement the scalability, we can upgrade the softwares. Databricks is going to use some versions called Databricks runtime version. So they have different versions like Databricks 12.2, 13.2, 14.2, 15. They are releasing more number of versions as a part of an upgrade. Suppose if your system supports only the older version, you still have a flexibility. Whenever you are creating a cluster, you can use that version of a Databricks cluster. And in case you want to use the latest version, you can choose the latest version of a cluster and use to run your notebooks using the latest version features of an Azure Databricks. So you have an option of implementing an upgrades in Azure Databricks. And recovery, in case if your nodes goes down, your data will not be lost. You will be able to recover the data automatically using the failure recovery model. So these are all the advantages we have with the Databricks environment. Okay, and coming to Azure Databricks, we are getting all the benefits of the Spark. But Databricks took up this open source tool, customized the open source tool, and they have designed this tool to generate or to deliver the better performance here. And along with that, Microsoft has hired this, purchased this Databricks, and they are going to release this service as their first party product in their cloud applications here. So that's how the Databricks has become the Azure Databricks. So the implementation of a Databricks has started like this. The evaluation is initially it started as a Spark, and then Databricks took this Spark, implemented a lot of optimizations, infrastructure, okay, and then they are releasing it as a product called Databricks. Then Azure acquired this Databricks and they changed that product with the name as an Azure Databricks. This is how the Azure Databricks was introduced. Okay, so this is an example of a code how we are going to write using the Databricks and using the notebooks of a Databricks to perform a variety of an operations. Okay. And if you want me to cover more about the Databricks, you can see here, it's an extremely powerful in-memory analytics engine built on cluster computing technology, the Spark cluster computing technology. So the advantages of a Spark cluster computing are it supports the in-memory data processing and it supports the parallel or distributed processing. Okay, and this is your Spark architecture. Okay, so Spark has variety of an operations here. It supports the Spark SQL, which can be helpful for implementing the structured processing. It supports streaming, which will be helpful for implementing the data streaming process. MLib, it can help you to implement the machine learning libraries, and you are able to even perform the graphics computations. And if you want to start working with your Spark, you need to work with any one of the Spark supported languages. There are 5 languages that are supported on the Spark. Those are mainly Scala, Python, SQL, R, and Java. These are all the 5 different languages that are supported on the Spark. Okay. And I want to cover a bit about RDDs because most of the time, whenever you are planning to work with the Databricks, our main work is mainly depending upon this RDDs only. Okay, it is mainly on the RDD front. So I want to cover what is this RDDs are, and then we can able to perform an operations using. We'll show you some kind of a lab, like how to set up the Databricks workspace, how the environment looks like, how we can write some of the commands using notebooks, and we will take it from there here. So what is an RDDs? Okay. So whenever you are going to work with a file, a data file, and you want to process a data using a Databricks or a Spark, I'm going to use this concept called an RDD. So RDD is one of a data structure, okay, of the Spark. It was stored in the memory of a cluster. So every file that you are going to work with, you have to convert that file into the form of an RDD. Okay, and these are the characteristics of an RDDs. Like it was split into the form of multiple partition. RDD is nothing but a data set, resilient distributed data set. See what CSV file, which is having some 1 lakh records inside it, or you have a JSON file, you have a Parquet file. Whenever you start processing this file using a Spark, it is going to convert that file into the form of an RDD, and it stores that RDD in the form of memory. And it has multiple options like RDDs are partitioning. So we are going to distribute that RDD into small chunk. Suppose I have to process some 10,000 records. I will create multiple RDDs, and each RDD consists of some chunk of a data. And the advantage of implementing a partitioning is if you have some number of 5 systems or 10 systems, I can take one RDD per system and I can execute all these RDDs at once in parallel. So I can able to enhance the power of the performance. I can uh, reduce the response time, increasing my processing capability by running this data set, by processing the data set in parallelism. So that's the advantage of using this partitioned RDDs here. Okay, and in memory, all the RDDs will be stored in the memory of a cluster here. Okay, so whenever you are trying to read the data or write the data, you can able to perform an operations in a much faster manner than reading and writing the data from the disk. We have another concept called read only. So the concept of read only is once you created an RDD, if you are making any changes to it, you cannot make any changes to this existing RDD. Instead, you can make a changes and store the changes in the form of a new RDDs. Okay, so you cannot modify the existing RDD here. And resilient, suppose due to some issue with the cluster, it is storing some portion of a data in the memory. If that portion of a data is lost, you need not worry about it. RDD are having a feature called auto recovery. They will be able to recover automatically on the other node, the new node which is added to the cluster. It will be able to fetch that information which was stored in the memory of that node, and using that memory, you can able to continue its processing. This is the concept of resilient. Okay, so I told you about what is the RDDs. You will be able to perform 2 operations on the RDDs. One, you can able to implement some kind of a transformation, and the second one, you will be able to implement some kind of an action. So transformation, if you are going to convert the data, shape, filter the data, arrange the data in a proper order, apply the structure to the data, joining multiple data sets. These are the examples of transformations. Okay, the way that you are actually changing your data is a concept of transformations. And there is another one called an action. So what is the concept of action here is in while you are working with the Spark, Although you implemented some kind of the transformation, it is not going to affect permanently until and unless one action is being called. Till that time, it just creates an execution plan, like what steps I need to follow, in what way I need to implement it. But if you want to actually execute the task that you have given, you have to use an action called, you have to use a command called an action. In action, under actions, there are multiple commands that we can use, like display, show, print schema, execute. There are multiple options that we can use to complete a particular task. Okay, so those are called actions. As I told you, transformations are they are changing the data here. They are applying some kind of a business logic. They are helpful to change the type of a data from one format to another format and arranging the data in an order. We can do a lot of operations using these transformations. As I told you, transformations are very, very lazy. You cannot implement the transformations until and unless an action is being performed upon. Okay, until you implement an action using a command like df dot print schema, df dot display. Okay, then only this transformations will get executed. Till that time, it will not get executed. And I have shown you, right, the partitions, right? This is the data set which I have passed in the form of a CSV file that will be distributed in the form of a small chunks here. And these chunks are being executed by the multiple nodes of a cluster. So one node in this picture is executing 3 chunks. Second node is executing 3 chunks. Third node is executing 3 chunks. So parallelly, 9 chunks of data is being processed rather than processing only one single portion of a data. And once the data is processed, it is going to load the data into the data set again. So this is a concept of partitioning here. Okay, actions are the operations. Like if you want to store the data somewhere, like df.save, df.write, you can use some of the commands to permanently store the data into the system again. So then we are going to use some kind of actions. Or if you want to display the information, or if you want to get the schema of that, you will be able to use these actions. Okay, so we already covered about this architecture here. Currently in Azure Databricks, we will be using a concept called data frames, which is more advanced than the RDDs. If you want to perform an operations using the files like CSV, JSON, Parquet, and you want to apply some kind of a schema over that existing data, which are stored in the form of a file. If you want to enforce some kind of a schema and you want to perform some kind of a transformation, then we will be using this option called in data frames. So data frames are actually built on top of the RDDs. They are actually in memory. Same thing, same applicable to RDD. Okay, partitioned, read-only, and resilient. But the advantage of a data frame over RDD is it is organized into the form of a naming column. You can impose some structure on top of an RTD here. Okay, and not only that, while we are executing some process, while we are performing some operations, Spark Engine will use some kind of an optimizations. Like optimization is what is the best way to execute and perform an operations. So Spark Engine can help us to implement some kind of an operations here. Okay, so there is a catalyst optimizer which will help us to execute multiple optimizations to enhance the performance of the Spark. And data frames mainly help us. It acts like a SQL. In whatever the way you are running some queries against the SQL server, you will be able to run some queries against the Spark and you will be against the data frame using Spark and you will be able to fetch the data from this data frames. So that is about your data frames here. Okay. So I told you about using the Spark on the Databricks. It supports in-memory parallel distribution of a data, and it supports multiple languages, Scala, Python, R, Java, and SQL, and it supports all the use cases. We discussed about this as well. We can implement an automation. We can implement the best security features, and we can collaborate with other people in the team members, infrastructure management. We can implement this architecture. Okay. So I can skip this as we already covered many things here. So just few things I want to cover about your Databricks environment. Okay, so we can go ahead and provision the Databricks. Let me show you how we can create the Databricks environment and what are the assets we have in a Databricks. And then we will discuss more about the Databricks here. Okay, just give me 1 minute. So we can log into the portal like this. This is your Azure portal. In case if you want to create or start working with the Databricks, you need to create a Databricks workspace. That will be our first step. So I can go here to the create and I will be able to create a workspace to start working with my Azure Databricks. So for that, you need to specify the details like your subscription details, your resource group. So I can select the resource group, whatever the resource group I want to use. I can select this resource group like a Databricks. And then you have to specify the workspace name for it. So by workspace name, we can say it as demo. I will be using as SpringPeople demo. Okay, ADB workspace. You can use any workspace name. Okay, and you can select a region to which region you want to use while you are creating a resources. So I can select the region as an East US. And coming to the licensing option, the pricing tier, there will be three pricing tiers mainly. It will come up with a trial version and also it will come up with standard or the premium version. Standard version is a basic. So we are going to use the premium version. So standard means it can make use of all the Spark features. It can secure with your Active Directory for logging and performing an operations. If you want in-depth more features to perform an operations with the Spark, then I have to use this option called the premium. Premium along with the standard, it also have some advanced options in terms of security called role-based access controls. Okay, role-based access control. So the concept of role-based access controls are, it will help you to define the role. Say for example, you are from an application team. All you have to do is use the Databricks and read the information from the Databricks. You don't want to have a control on performing an operations, admin operations on the Databricks. So I will limit you to perform an operations with just reading the data. For admins, I want to grant permissions to perform all the admin related operations. So I can control the access using this role-based access control. So I can go ahead with the premium. And then you need to select the manager resource group name. What is the concept of manager resource group is, as we discussed, the Spark cluster is a combination of multiple systems that are being used, multiple servers, okay, 30 servers. We are calling it with the name of the servers as a nodes as per the cluster technology. So we are using more number of nodes. So, and we are also configuring an auto scaling option. If the existing number of nodes are not sufficient, go ahead and increase the number of nodes, decrease the number of nodes, adjust the node based upon your usage. So if you want to use such node mechanisms, okay, what the number of nodes that are creating will be completely maintained by the Databricks itself, not us. So in that case, I'm going to create another resource group called manager resource group. I can say SP demo MRG, which is a manager resource group. Manager resource group. Okay, so these are all the inputs that I have need to create. And if I go to the networking section, here you can provide the networking details like, do you want the Databricks cluster with a secure cluster connectivity? If you say yes, then you need to set up all the networking, the VPN details and everything. No, everyone will be able to access the URL to connect to the cluster and perform an operations. In real time, we will be using an S only. And do you want set up the Azure Databricks workspace to be set up in a private network? Yes, and you need to set up your networking configuration here, like your VNet, subnet, which network IP addresses should have an access to your Databricks clusters and Databricks environment. At this point of a time, I'm saying no, so that using that URL, you will be able to connect and perform an operations within Azure Databricks. And then who will be implementing and how we'll be implementing an encryption. So we are taking the help of an Azure to implement that default encryption, okay, for the data that has been stored in DBFS. DBFS stands for the Databricks file system, which will act as an abstraction layer for storing the data through ADLS. And it will help us while you are reading the data from ADLS into the Azure Databricks or writing the data from Azure Databricks into the ADLS. It makes sure the data is encrypted. Okay, no other hacker can able to hack this information. If you want to implement that kind of an encryption, I can simply select this option here. Okay, so this is related to encryption. I will go with the basic options at this point of a time. And I can go with the security and compliance, go with the basic options, and then tags are like a label. And finally, I can use this review and create. This will help me to create a Databricks workspace. Let this Databricks workspace be created. It will take around 2 minutes. Then I will explain you about your Databricks environment. In the meanwhile, if you have any questions, let me go through it and feel free to post any questions if you have. I can answer your questions. Okay. So the deployment is completed. So your workspace is ready. In case if you want to start working with your Databricks workspace, you can go here and you can verify the properties. It is active, the resource group name, location, subscription. You can see the URL. Using the URL, also you will be able to connect and launch the Databricks workspace. Or else simply you can click here. This is going to launch your Databricks environment to work with. Okay, so this is your entire environment where we can start working with using your Azure Databricks. So I can use this new option to create any notebook. There are few assets that we are going to create inside the Databricks. Okay, those assets are, we can get the compute ready, the cluster ready, so that you can run any kind of a workload using that compute. Second one is we can able to create some kind of a notebooks. Notebooks are the interactive objects using which you can able to execute some queries against the Databricks. And while you are creating these notebooks only, we will be able to work with all these languages, all the 5 languages like SQL, R, Java, Python, okay, and Scala. You can use any one language here. Okay, so you can see this. This is my workspace. Any object that I'm going to create, I can create it here and start working with an Azure Databricks workspace. Recently, if you have opened any kind of a notebooks or if you have created anything, you will be able to fetch the notebook and start using the notebooks for performing an operation. Catalog is a place which acts as a repository for uploading and working with the data within the Databricks environment. Like if you have any ADLS, you can mount that ADLS into the Databricks workspace, use the files that are stored in the ADLS, and then you will be able to perform an operations using the Databricks commands here. Workflows are used to implement some kind of an ETL mechanism. So all the ETL can be implemented using the Databricks itself. And if you want to create some kind of a compute like the Spark cluster, what we have discussed, you can create the Spark clusters using this compute option. And marketplace is, suppose from the Databricks, if you want to connect to any other third-party tools like a Power BI, okay, to implement the reporting, okay, DBT Cloud to pull the data from, Tableau to create some kind of a reporting. If you want to connect and work with any kind of an tools, ETL tools, you will be using this kind of an marketplace here. Previously, this marketplace is called as an partner connect. And if you want to work with the Databricks by performing for dealing with the structured data, you can use the Databricks to run the SQL queries. So for running the Spark SQL queries, we will be using the SQL editor, queries, dashboards, alerts to perform an operation. This part is completely whenever you start working with the Spark SQL part. And in case if you want to implement some kind of orchestration, automation inside the Databricks, then we will be using this option called jobs. Jobs are one way to automate all the operations that has been implemented inside the Databricks. And we can also implement some kind of data ingestion process. Data ingestion is a concept of receiving the data from different source controls here. And we can also create some kind of a delta live tables. So data will be stored in the form of a delta table, and you will be able to write some queries using this delta live tables command. And if you want to work with the machine learning libraries, you will be able to use this machine learning libraries to perform an operation. So you'll be performing a lot of operations. It's not just limited to a data engineer. You can, the same workspace can be useful for the data analyst, data scientists, data engineers. Everyone will be using the same workspace to perform an operations. Okay, so let me quickly show you how to create a cluster and how to work with the cluster. Okay, so I can create a compute option here. While I'm creating a cluster, I'm using this option called unrestricted, so anyone can make use of a cluster. I want to create a single node cluster. That cluster access should have on my username, but you can also allow the other users to access the same cluster. I'm choosing this 15.4 version of a cluster. And here you will be able to select what node of a cluster you want to use with. So I can select any kind of a node here. Okay, this is my configuration. I'm selecting around 4 nodes, 8 GB. So you can see here, I don't know this much of configuration. I want to go with the basic configuration. That is, this is fine for me. I want to just get 32 GB of a memory, 4 cores, so that I will be using less cost. If I use more configuration, I need to end up paying more. So depending upon your workload, you need to choose how much configuration will be sufficient. And I can able to configure this cluster termination. In case if the cluster is idle, you are not performing any operations, okay, using the cluster, then you can configure the auto termination. It will be stopped automatically after 15 minutes of an idle time. And then you can go ahead, and this is your summary for the cluster that you are creating. If I say create compute, this is going to create a cluster. So if you want to perform any operations with the Databricks clusters, then you have to implement this option called a cluster. You need to start creating a cluster, building a cluster, and then only you will be able to perform an operations with the cluster. So this is how we can create a clusters. And once you create a cluster, if I have to create any kind of a notebook to write the code on top of the clusters. Okay, so here you have a language. So I told you about 5 languages, right? We can use Python, Scala, SQL, R, and Java. So here in the 5, Java is not supported within the Databricks. Instead of Java, we have this Markdown language. So default language is Python. But in case if you want to run any other commands other than the Python, like a Scala, you have an option that you can change your default language as well. Okay, you can change it to Python or you can change it to SQL, Scala, any language that will be supported from here. So I'm selecting it to Python. But if you want to execute any queries, I can write a query here. Like for example, I want to see dbutils.help. Okay, this is one of a command. I want to see all the operations that I can do within dbutils. Okay, but if I have to execute this query, the first step I need to do is I need that cluster to be ready. The cluster is not yet ready. It was still provisioning. As soon as the cluster is ready, I will be able to run this and perform some operations using Databricks. Till that time, I will not be able to run any queries here. Let it start the cluster provisioning. Let it be ready. So once it is ready, you can see the green mark here indicates the cluster is ready. You can go ahead and start using the cluster. Okay. Then I can able to run all the operations using the Azure Databricks. So you can use the Python language here to write all the queries which we will be learning to implement all the transformations. Still loading. So in the meanwhile, if you have any queries, you can post it in the chat window. I can take it up and answer those since we are running short of a time. So every query that you are executing, it will be connecting to a cluster. This cluster has multiple configuration. Okay, at this point of a time, I have created a single node cluster, but you can create a cluster with multi-node and it will, whatever the query that you are executing, it will distribute across the multiple nodes and execute all at once. That will enhance the performance of your queries. Actually, this is the basic concept of Databricks, but if we really walk through Databricks, there are 1 hour is not sufficient. It's very, very huge. There are a lot of new concepts that are coming in with the Databricks here, like Unity Catalog, Delta Lake, There are many things that we can implement inside the database. You can run the queries using this option. You can connect to a cluster. You can able to schedule it using automation. Say, for example, whatever the code I have written here, if I want to automate this code execution, I want to run this code to, like I want to schedule this code to run at 8 p.m. daily. So I have an option, I can use the schedule option to create the scheduling as well, rather than executing it manually. If you want to execute it manually, you can use this option and run cell option. This will execute it. Okay. Or else you have an option. It has to wait until this cluster is ready. And once the cluster is ready, then only it will be able to execute the query. I think the cluster is ready now. This is the cluster we connected to. This will execute the query and show you an output. This is the output of your query. Okay. So like this, you will be able to run the queries. You can see the execution time of a query, and you can perform various operations using the Databricks here. Okay. Collaboration, you can also share this notebook to multiple people. So they will able to read the entire code. They can modify the code depending upon the permissions you granted to them. So that's it from my side, Ankita.
Thank you so much, Ramon, for such an engaging and insightful session. I'm sure everyone here has picked up strategies and techniques they can apply immediately. If you guys are interested in learning more about Azure Databricks, check out our discounted batches of virtual instructor-led trainings on our website, springpeople.com. These VILT trainings are leveraged online from the comforts of your home and flexible as per your schedule and location. If you do not find any suitable batches, we'd be happy to discuss and schedule private batches for you. If you don't have time to join live online, then do try out our affordable self-paced courses. For more information, do write to us at training@springpeople.com or call on our number displayed on the current slide. Thank you, everyone. We appreciate you being here. We shall be sending out the webinar recording to all you participants soon. I request you to kindly provide feedback before signing off, which will really help us improve the quality of our future events. Thanks again for joining us today. Signing off on behalf of Team Spring People. Hope to see you again for our next expert webinar. Take care. Bye.